Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain and today we will discuss about polynomials, especially for the relationship between zeros and coefficients, which we discussed in the introduction part also in the last lecture. So let's revisit that concept first. What we discussed was, in case of quadratic polynomials ax square plus bx plus c, let us say this is the standard quadratic polynomial where a is not equal to 0, a, b, c are real numbers, right? What was the relation between zeros and coefficients? Let's say zeros are alpha, beta here, right? So we saw that alpha plus beta was equal to minus b by a, or we can say coefficient of x divided by coefficient of x square with a negative sign, right? And what was the product of these zeros? This was equal to c by a, which is constant term divided by coefficient of x square, right? So this was the relation for quadratic polynomials. And for cubic ones, let's say the standard form is this: ax cubed bx square cx plus d. What was the, let us say zeros here are alpha, beta and gamma. Okay, what was alpha plus beta plus gamma? It was equal to minus of b by a, which is equal to minus of coefficient of x square divided by coefficient of x cube, right? What was alpha beta plus beta gamma plus gamma alpha? That is sum of roots taken 2 at a time, right? Alpha beta, beta gamma, gamma alpha, and then sum. What was it? It was equal to c by a, which means coefficient of x divided by coefficient of x cubed, right? And what was alpha into beta into gamma, product of roots? It was equal to minus d upon a, which means minus of constant term divided by coefficient of x cubed, right? So this we did for some of the questions where we verified the relation between zeros and coefficients also. So let's move on to the next exercise, where the questions are like this: verify that the numbers given alongside of the cubic polynomials below are their zeros. Also verify relationship between zeros and coefficients in each case. So now you need to keep in mind that the standard polynomial I will consider is ax cubed bx square plus cx plus d. Obviously a is non-zero and a, b, c, d are real. This goes without saying, okay? So this is the cubic polynomial that we will be dealing with. So let us first of all consider this one. Let us say f of x is equal to 2x cube plus x square minus 5x plus 2. Now, first of all, the question wants us to check whether 1 by 2, 1 and minus 2 are the zeros of this polynomial or not. So to check whether these are zeros or not, we will just put x equal to 1 by 2 first on both sides. If this expression becomes 0, then we can certainly say that 1 by 2 is a 0. Otherwise, it is not a 0. So let's put 1 by 2 in place of x in all the places and then calculate it. 2 into 1 by 8 plus 1 by 4 minus 5 by 2 plus 2. So this will become 1 by 4. 1 by 4 plus 1 by 4 will become 1 by 2 minus 5 by 2 plus 2. So 1 by 2 minus 5 by 2 is how much? Minus 4 by 2, which is equal to minus 2. So minus 2 plus 2 equals 0. So yes, we can say that 1 by 2 is a 0 of this cubic polynomial. Similarly, we can check for 1, f of 1. So put x equal to 1 in this expression. So it will become 2 into 1 cubed, 1 squared minus 5 into 1 plus 2. Okay, so it will give me 2 plus 1 minus 5 plus 2. 2 plus 1 3 plus 2 5 minus 5, which is equal to 0 again. So yes, 1 is also a 0 of the given cubic polynomial. So let's check for minus 2 now. Similarly, you put f of minus 2. So it will become 2 into minus 2 cubed plus minus 2 squared minus 5 into minus 2 plus 2. Right? So it will give you 2 into minus 8 plus 4 plus 10 plus 2 minus 16 plus 16. So yes, at x equal to minus 2, this polynomial will become 0, hence minus 2 is also a valid 0. So now these three are zeros. So what is sum of these zeros? I will consider the zeros as alpha, beta, gamma. Okay. So this is the standard form that we will consider. Okay. So don't get confused when I write alpha plus beta plus gamma. I am just saying the sum of zeros. So what will be the sum of zeros in this case? 1 by 2 plus 1 plus minus of 2. So it will become 1 by 2 minus 1, which is equal to minus 1 by 2. Right? So, and to verify whether it verifies the relation or not, what is alpha plus beta plus gamma? It should be equal to negative coefficient of x square by coefficient of x cubed, right? And what is coefficient of x square here? It is 1. What is coefficient of x cube? It is 2. So it should be equal to minus 1 by 2, which is correct. So alpha plus beta plus gamma is minus 1 by 2 and the relationship is verified. Now if I take sum of roots taken 2 at a time, it will give me 1 by 2 into 1 plus 1 into minus 2 plus 1 by 2 into minus 2. So it will give me 1 by 2 minus 2 minus 1, right? 1 by 2 minus 3. So it will give me minus 5 by 2, right? And what is sum of roots taken 2 at a time in our relationship? It is equal to c by a, that is coefficient of x by coefficient of x cubed. So what is coefficient of x here? Minus 5. Coefficient of x cubed 2. So yes, this is also verified because it is equal to coefficient of x divided by coefficient of x cubed. So yes, it is also verified. Now look at alpha into beta into gamma. What is alpha into beta into gamma? 1 by 2 into 1 into minus 2. So it is minus 1. And what is it in our relationship? It should be equal to negative constant term divided by coefficient of x cube. What is constant term here? Constant term is 2 and coefficient of x cube is 2. So minus of 2 by 2, which is equal to minus 1. Hence this relationship is also verified, right? So if you notice, the next question is exactly on the similar lines. What you have to do is you have to write it as f of x minus 2. Then you have to verify whether these are zeros or not by putting values of x as 2 and 1, right? Because these two zeros are same. Okay, so you just have to check two values. Let's check it. So it will give you 8 minus 4 into 4 16 plus 10 minus 2. So it will become 18 and it will become minus 18. So 18 minus 18 equal to 0, right? So 2 is a 0 of this polynomial. So let's check for 1 now. Put x equal to 1 here. 1 cubed minus 4 into 1 square. So it will give you 1 minus 4 plus 5 minus 2, right? Plus 6 and minus 6. So it will give me 0 again. So yes, 2, 1, 1 are zeros of this polynomial. Now to verify the relation, again let's see sum of roots taken one at a time. That means alpha plus beta plus gamma, where alpha, beta, gamma are zeros, right? What is it equal to? 2 plus 1 plus 1 equal to 4. And what should it be equal to in the relationship? It should be equal to minus coefficient of x square divided by coefficient of x cube, which is equal to minus of, what is coefficient of x square? It is minus 4 divided by coefficient of x cube, it is equal to 1. So yes, the relation is verified. So these questions are very simple for you now. You can verify alpha beta plus beta gamma plus gamma alpha also. It will be equal to 2 into 1 plus 1 into 1 plus 1 into 2. So it will give you 2 plus 1 3 plus 2 5, right? And it should be equal to what? It should be equal to coefficient of x divided by coefficient of x cube. Coefficient of x divided by coefficient of x cube. What is coefficient of x here? 5. What is coefficient of x cube? 1. So yes, it is also verified. Similarly, you can do it for alpha into beta into gamma, which is 2 into 1 into 1, 2. It should be equal to how much? Minus of constant term divided by coefficient of x cube. What is constant term? It is minus 2. So minus of minus 2 divided by what is coefficient of x cube? It is 1. So it also is verified, right? So this is how we verify that these are zeros of a cubic polynomial. We do it by putting x equal to that number and then finding that it is giving me 0 or not, and then to verify we just need to put it in these relationships, right? Now the reverse process. You need to find a cubic polynomial where sum means alpha plus beta plus gamma, sum of the product of its zeros taken 2 at a time, which means gamma into alpha, and the product of its zeros, that means alpha beta into gamma. These are given as 2 minus 7 and minus 14, right? We can derive a general expression for this also. What we can do is, if it is a cubic polynomial, we can write it as x minus alpha, x minus beta, x minus gamma, right? I'll tell you a general expression for this so that you can simply put the values and find the required cubic polynomial. Now when you multiply these three brackets, what will be the coefficient of x cube? It will be 1, because x cube can be formed only when x comes out from all these three brackets, right? Now what will be the coefficient of x square? When this minus alpha is multiplied by this x and this x, so minus alpha x square, right? When this minus beta gets multiplied by this x and this x, minus beta x square. Similarly minus gamma x square. So the coefficient of x square will be, right, what I have done is minus alpha x square minus beta x square minus gamma x square. So I have just taken minus of x square common, alpha plus beta plus gamma, right? And how do we create alpha beta plus beta gamma plus gamma alpha in this? What will be the coefficient of x? X will become when minus alpha into minus beta into x from this bracket will come. So it will become minus alpha minus beta into x. So alpha beta x, right? When minus beta, when x comes out from this bracket, and minus alpha and minus gamma from these one, so it will give you minus alpha minus gamma into x. So it will become alpha gamma x. Similarly minus beta into minus gamma into x will give you beta gamma x. So what will be the coefficient of x? It will be alpha beta plus beta gamma plus gamma alpha, right? And what will be the constant term which will have no x in it? It will be when these three get multiplied, minus of alpha, beta, gamma, right? So I can write a cubic polynomial in general form as x cubed minus sum of zeros taken one at a time into x square. Sum of zeros taken one at a time is nothing but alpha plus beta plus gamma, plus sum of roots taken two at a time into x. It is nothing but alpha beta plus beta gamma plus gamma alpha, minus S3, which is alpha into beta into gamma. So now in this question these three are given. What you can do is you can simply replace these here. S1 is 2 into x square, plus what is S2? It is minus 7 into x. What is S3? It is minus 14, right? So the required cubic is minus 7x plus 14. So this is your required cubic. Okay, so this was the reverse process. How to find a cubic polynomial when the sum of zeros taken 2 at a time and sum of roots taken 3 at a time, or the product of all the zeros is given, right? So this can be put in this standard form. Okay. Now if the zeros of polynomial are these three, find a and b. Now from our previous knowledge we know that sum taken one at a time, or let's denote it by S1, right? Sum taken one at a time means a minus b plus a plus b. It should be equal to minus of coefficient of x square divided by coefficient of x cube. So minus of coefficient of x square is 3, it is 1, so it will be equal to 3, and so it will give me, b gets cancelled here, 3a equal to 3, hence a equal to 1. So I get the value of a. Now I need to find the value of b. So now if you notice, rather than calculating sum taken 2 at a time, if I calculate the product, it will become easier. What is the product? A minus b into a plus b, right, where a is 1. So the product is, what is the product of zeros taken 3 at a time, right? What is the product? It is minus of coefficient of, minus of constant term divided by coefficient of x cubed, right? What is the constant term here? Minus 1. And what is coefficient of x cube? It is 1. So this product should be equal to minus 1, right? Let's put value of a as 1. So 1 minus b, this will become 1, 1 plus b, it is equal to minus 1. So a minus b into a plus b will give me a square minus b square. So it is equal to minus 1, hence b square is equal to 2. So what is b? It is equal to plus minus root 2, right? This is how we find values of a and b here. Okay. So let's move on to this one now. This is a biquadratic polynomial. So how many zeros will be there in this polynomial? There should be 4 zeros, right? They can be equal, but there will be 4 zeros, right? Where 2 zeros are given. Okay, let us say the biquadratic this is given, right? 2 zeros are given, which are 2 plus root 3 and 2 minus root 3, right? So if I ask you, how did these 2 zeros came? Because this biquadratic can be written as x minus alpha, x minus beta, x minus gamma, x minus delta, let's say, right? It can be factorized into 4 linear factors, and these two linear factors, if clubbed, will give me a quadratic polynomial. If I make a quadratic polynomial from these two zeros, that quadratic polynomial will be a factor of this biquadratic, right? So considering these two zeros, what is sum of these two zeros? 2 plus root 3 plus 2 minus root 3, which is equal to 4. And what is the product? 2 plus root 3 into 2 minus root 3, which is equal to 4 minus 3 equal to 1. So a quadratic polynomial consisting of zeros 2 plus root 3 and 2 minus root 3 will be x square minus 4x plus 1, x square minus sx, sum of roots and product, right? X square minus 4x plus 1. So now this quadratic will completely divide this one, okay? Why? Because it is a part of this, it is a factor of this biquadratic. Okay, so let's divide it by this quadratic. This is 35. Okay, so let's divide it by x square minus 4x plus 1. Why are we dividing it by this quadratic? It is because this biquadratic consists of two factors, let's say, out of which one is this one. We are finding the second factor. And why do we know that this is one of the factors? Because these two zeros are given, and these two zeros will make this a factor of this biquadratic. So let's divide. And how do we divide these kind of polynomials? We just concentrate on first terms first, right? How do we make x raised to power 4 from the first term of this? By multiplying by x square, right? Now if I multiply this by x square, it will give me x raised to power 4 minus of 4x cubed plus x square, right? Then I subtract, right? This is the usual way. So x raised to power 4 gets cancelled here. This will be minus 2x cube minus 27 x square plus, write the rest of the terms as it is. Now repeat the same step again. Concentrate on this term and this term. How do we create this term from this term? By multiplying it by minus 2x, right? When I multiply x square by minus 2x, it will give me minus 2x cubed. Now write the rest of the terms. Plus 8x square minus 2x, right? Then subtract again. This term will get cancelled. Minus 27 minus 8 will become minus 35 x square plus 140 x minus 35, right? So now again consider that if I multiply this term by minus 35, it will give me this term, right? So let's multiply. So it will give me minus 35 x square. Minus 35 into minus 4 is how much? 35 into 2 is 70, 70 into 2 is 140. So yes, it is 140x. And minus 35 multiplied by 1 will give me minus 35. So we got the exact expression. So change the signs here and it gets cancelled. So it will give me 0. So yes, this was one of the factors and this is my second factor. So I can write the given biquadratic as x square minus 4x plus 1 into x square minus 2x plus 2x minus 35, right? So now the product of these two quadratics will make my original biquadratic equation. So now I've got the zeros of this quadratic already. I just need to find the zeros of this one, right? This was the original question, find other zeros. So other zeros will be given by this one. So just factorize this quadratic by splitting the middle term like this. So x common, x minus 7 plus 5 x minus 7. So x plus 5 into x minus 7. So now the other zeros will be x equal to minus 5 or x equal to 7, right? So if I collectively write all the zeros are 2 plus root 3, 2 minus root 3, minus 5 and 7. So this is my answer, right? Okay, let's move on to this question. This question is simply a division question. Now let's divide. X raised to power 4 minus 6x cubed plus 16x square minus 25x plus 10. It is divided by another polynomial, which is x square minus 2x plus k, right? And the remainder comes out to be x plus a. Find k and a. So the idea behind doing this question is we will just divide it by this quadratic and then see what the remainder we get, and then we will compare that remainder with this given remainder. Okay, so let's start dividing. The algorithm is same. I need to create this one from this term. How do I create that? By multiplying this by x square. So let's multiply by x square first. So it will give me x raised to power 4 minus 2x cubed plus kx square. Now subtract. This term gets cancelled. This will give me minus 4x cubed plus 16 minus k x square. Rest of the terms as it is. Okay. So now to create this one from this, I have to multiply by minus 4x. So minus 4x cube minus 4x multiplied by minus 2x will give me plus 8x square, and minus 4x when multiplied by k will give me minus 4kx, right? Now subtract, cancel. Now x square 16 minus k minus 8, 16 minus k minus 8 into x square, and this one is 25. So let's take plus 4k minus 25 into x, right, plus 10. Okay, I have just written it other way around. It was minus 25 plus 4k, or you can write it as 4k minus 25. It is one and the same thing. So now this term has become 8 minus k, right? So I can write this term as 16 minus 8 equal to 8 directly. So let me write it as 8 here. Okay. So now to create this term from this, I have to multiply it by 8 minus k, right? So if I multiply it by 8 minus k here, it will give me 8 minus k x square, right, plus 8 minus k into minus 2x. So it will give me 8 minus k into minus 2x. I can bring this minus sign here, right, and 2 here. So it will be 2 into 8 minus k x. Now 8 minus k when get multiplied by k will give me 8 minus k into k, 8k minus k square. Now we will subtract as usual. Minus, we will change the sign here, here and here. So this term gets cancelled completely. So this will become 4k minus 25, right? This is with a plus sign, plus 16 minus 2k into x, right? So these two terms are taken care of. Now let's take care of constant terms. Plus 10 minus 8k plus k square. Okay, so this is the remainder that we get. Now the degree of highest term of x is 1. So this is perfectly our remainder now. But the remainder in question is given as x plus a, right? So now the idea is to compare How do we compare? We compare the coefficients. Coefficient of x in the given remainder is 1, but in our obtained remainder it is 4k minus 2k is 2k, minus 25 plus 16 is minus 9. So it is equal to this one, 1, right? So what is k? K is 9 plus 1 by 2, which is equal to 5, right? Whole idea was to get the value of k and a, right? We have obtained the value of k now. So now we will obtain the value of a. What is a? A is a constant term, right? And what is the constant term here? This is my constant term. So a is equal to 10 minus 8k plus k square. Now put the value of k here. (20 plus 10 is 35, 35 minus 40 is minus 5, right? So we have obtained value of a and value of k, right? So this is how we do questions like this. So this is about this exercise. Now in the next exercise we will do the other question which are based on division algorithm, right? So thank you.